Good afternoon, ladies and gentlemen of Algebra 2 Honors. Today we're going to be working on something called identities. And here we're going to use and verify different polynomial identities. And do you have an idea of what an identity is? Well, it's a basic formula. Now, one thing that people talked about when they took the PSAT a few weeks ago was they ran into a problem where this identity would have been very helpful had you known about it. And what is this equal to?
X plus y and x minus.
Yeah. So this is an example. In fact, this is one of the identities we're going to be exploring today. And then there are other identities. And this is an identity also for factoring. And so these are equal to each other. And so in these first exercises through 16, we're essentially proving the identity by working it out. And so how would you work this one out here, number 12? Now you could go like this. What you could do is you could write x plus y plus z, and just rewrite this here, x plus y plus z, and then you could distribute, right? Distribute, 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 and then we could distribute these guys here, right? And then this one here. But if you want to do it that way, you can do it. But I find that it might get a little cluttered this way. So one thing that avoids the clutter with this is what we talked about yesterday, which is setting up a box. You need to make a box big enough for you to see polynomials on the top and the left simultaneously. Okay, and so we put x, y, z, x, y, z, and then multiply the terms together in the space where they intersect. X times x is x squared. You should know how to do the rest. This is xy, right? And this is xz. And this is going to be xy, y squared, and then yz. And this one here is xz. This one here is yz. And this one here is z squared. And then combine the like terms, and you can see that we have like terms here. We have like terms here. These are two like, so I'm kind of circling all these things are like terms. And then we have x squared plus 2xy plus, well actually, I can put them in the order they have it here originally, right? I can just write it like that. That's what I'll do. I'll write it in the order they have it here. Plus 2xy plus 2xz and plus 2yz. And so that's going to be a verification. So basically what you're doing, I had a question about entering 7th period from Victoria about this, and she asked the question, are you trying to see if they are equal to each other? Well, that's actually a good question, but we know that they are equal to each other because what? We're told to verify, so they're telling us they're equal to each other. And so now it's just up to us to do some mathematics to demonstrate that that's indeed the case. Yeah, you can be right there. Okay? So I want you to do is work out number 13. I'll choose somebody here in a couple minutes, all right?
They go for what?
Because it's only
Because
day.
the A plus A box plus B
That's
box.
so long.
By itself.
Now on 13, what would you do?
I have no clue, I'm really
Would it
confused.
not be a,
Well, anybody have an idea on this?
Wait, would you do
Would it not be a
AG
5 by
and like
2?
do the exponent? You put a
is it the right side that you put in the 5 by 2?
Yeah, so Abigail's saying,
Doesn't matter.
the right way I do this, I would go ahead and work all this out. And to verify the identity, all this multiplied together and simplified should work out to be this. But this is really a factored form of this. Right? But if you multiply all these together and simplify, you should end up with this. Does that make sense? You guys are too busy to comment on it. Like,
I'm gonna wait it out.
Would it be false?
So if it's me, I don't know what, don't pick me.
That's what I do.
yes.
How would you know what being number 14?
Okay, we'll get to that one.
Because I'm looking at it, there's an easy to do on my calculator.
Let me see
There's
here.
3, like,
Yeah,
so you have to do like 1.
What you can do is you can multiply these first two together. You can multiply these two together first and then multiply by this.
Oh, okay.
That's one way to do it.
Wait, Kevin, did you already fill it out, right? So for the final, since we didn't leave the cancel line, everything is fine. So A5.
Did you find a simplified, did it simplify out nicely on this one?
Yes.
Yes.
Did, okay, let me go ahead and choose somebody for this.
Hopefully it's me.
So Kim or somebody else.
But now I don't know what
You, I know.
It'll be Bryce.
He said he didn't want it.
All right, Bryce.
No.
I don't think I did it right at all. But
You would just choose
I still got
A and
A and then B, which is what I started with, and then I rested it. Every one of those?
Only 5. Come on now.
So it just,
It's a simple
so A, B,
Huh?
what? How-
You have to say AA.
Oh.
I'm confused.
You're confused?
I can do it.
Let me go out and spin somebody else.
I'm confused.
Oh, man.
It'll be Addie or Mark's Addie. Yeah.
Addison.
I was hoping you'd come on.
All right, Addie, what do you got here?
So I did 5 by 2.
So do you get, like, you get 2 this way and
Yes.
5 this way? You did it like this, something like this? Okay. Sounds like, okay. We got this, this, and this, like that, Addie, is that right?
Yes.
Okay,
And then on the left side, I have A and B.
okay.
And then on the top, I have the other equation.
It's going to be 600.
A to the third b, is that it?
Yeah.
And this one here is a squared b squared, right? A squared b squared. And then negative ab cubed. And then b to the fourth, okay, and what?
And then in the first box I have a to the 5th power, and then negative a to the 4th power, b, a to the 3rd power, b squared, negative a squared, b cubed, ab to the 4th, a to the 4th times b, negative a cubed, b squared, a squared, b cubed, negative a b to the 4th, and then b to the 5th.
And what happens here?
And then everything canceled out, so the equation
Like
I
that.
got was,
Boom. Like this?
yes,
So what do you get left over?
a to the 5th plus b to the 5th.
Okay. Looks good. Does that look good, Bryce?
It's better than what I got.
Okay, that's fair. That's fair, Bryce. So go ahead and work out number 14. We had a student, seventh period, who had sort of a novel way of looking at number 14. So I want to share the wisdom from seventh period too. The 15 is more complicated. It is, yeah.
How do you get
What?
this negative?
What's 15? Just multiply these things out together. Yeah, do this too. So do it. Multiply this and plus that. Multiply that term. Then you get this. Somehow, it's really not the huge problem.
I don't know. I don't know how to just set it up.
All right, number 14. I'll tell you a strategy for number 14 that worked. Is what you can do is you can multiply, say these, you can multiply these together first, and then you find a product based on this. Then when you get that, after you get the answer to this, you take the answer here, and then you multiply that answer by this. You see that? You get an answer, a product here, and you take that and multiply it by this.
The first like set of those things, like the x minus y.
Yeah.
You do that times all of them. So it'd be like the last one basically. So it'd be like the x, y on the sides, and then that could be just two. It'd be a 2 by 5. Oh wait, 2 by 4, and then you do
Oh.
like x minus y.
Oh, so you're saying multiply that by everything?
Mm-hmm.
I'm not, you know something, I'm not sure that would work out.
Hey, can you do that?
Because you got to multiply these together, so it's not the same as having all these in one. So I don't think you can do that. You could try to see what you get on that, but Connor, I don't think that's going to work. Because you got to multiply these together. Now you can multiply these in any order. Like you can multiply these two things together first and then multiply by this. Why can you multiply things in different order? What property of algebra do we call that? Okay, it's called commutative property of multiplication, right? Doesn't matter which order you multiply things in.
I think I got it.
You got it, Kim? Okay, I'm gonna spin a wheel here.
Maybe.
Maybe, that's it. I like it, maybe. I like the hint of uncertainty.
So I got the thing.
So let's go ahead and take this.
Did you hear that?
I will spin this one here. Kim. Is it gonna be Kim or Gabby? It's gonna be Gabby.
Gabby. Darn it, I'm gonna be me.
Okay.
I actually knew them.
I saw the first two that you said, so I just went ahead and did, box. So I had 2 boxes in the beginning. But, I had x minus, x and a negative y at the top,
Yeah.
and then x plus y, and then plus 1.
So you got like this,
Yes. So, those
so these will
marked out.
cancel out.
So then I made another box and used those.
Okay,
So I had x squared and positive y squared,
right here, okay.
and then x squared and negative y squared. So that would be x to the power 4, and then x squared and y squared, and then negative x squared and y squared, and negative y squared to the power 4.
And then these cancel out,
Yes.
so you're ending up with x to the 4th minus y to the 4th. Okay, does that look right? I want to show
didn't do
you,
that first box, I just multiplied the first two together.
Yeah, that's what I did.
Yeah,
I did
and then got straight.
so you just kind of worked it out like this, is that right?
Yeah,
First, outside, and something like this,
yeah. And then I got,
yeah.
yeah.
Okay, yeah, you can do that too. And then when you get that, multiply, yeah, you can do that. I want to show you one thing that I had, that we had a student in 7th period who sort of worked out a 3D way of doing this one.
What an overachiever.
Now, he is an overachiever.
When I saw it, I was like, oh my gosh, he's really.
And so what we have here is but you see you can do this, right? So now, so you have, over here you have x, like x minus y over here. You have x plus y here. And then you put x squared plus y squared over here, plus y squared, and multiply these together. So right here, in this box here, you're going to get negative y times x squared. So this box right here is going to be x cubed, negative x cubed y. And you could do that for all of these, but where does this thing break down? It's hard to see behind, right, because you have some unhidden cells, but you see that conceptually this is a good strategy, isn't it?
Just confusing.
That's not the way I did mine.
Yeah.
I did like a two.
That's exactly how I did
I
mine.
did a 2x2 and then put them on 3
Yeah.
different sides and cut out those boxes.
Okay, let's go on to number 15. Number 15, has anybody worked out 15 yet?
No, I need to demonstrate.
We're there, yeah. This is one where that really takes a little doing.
So first, or just do the, on the left side, or
Okay, the thing about it is, why do I know I'm going to have to work the right side out first? Why do I know that?
just where?
Okay, the reason I know that is because what do I see over here that I do not see over here?
Negative.
I see a negative sign, right? So if I multiply this out, am I going to get any kind of negative sign possible from multiplying these together? No, I'm not. And so it's going to be possible with cancellation to get from here to here, but not directly from here to here. So that's kind of a clue about what you'll do first. And so you go ahead and take this out. What I would do is set up a couple boxes like this. So here we have ax minus by, ax minus by, and you just multiply these together, you get a squared x squared, and you get negative ax by here, and negative ax by here, and over here you get negative, you get actually positive b squared y squared. Okay, then you write all this out, you get your product here, you get a squared minus, you have two of these, 2ax by, and then you have plus b squared y squared. And then you do the same similar thing down here for this one, and you're going to put, you'll put bx plus ay, bx plus ay here, so you get b squared x squared here, and over here you get ax by, and ax by here too, and over here you get, in the lower right, you get a squared y squared.
When you wrote the equation for the first one, is it not a squared x squared minus 2ax by? Because you just put a squared, but shouldn't it be a squared x squared? Because
Not on the equation,
Oh, right here?
not on the equation.
On the actual equation, because it's got a.
Oh.
At the beginning of it?
Are squared.
Oh, yeah, sorry, yes, thanks for catching that. Yeah, a squared x squared, yeah. Thanks for catching that. Yeah, it's a squared x squared. I'm working fast, it's easy. So now we have, our product here is going to be b squared x squared plus 2ax by plus a squared y squared. And then you add all these together, you add these together. When you add both these together, these two things will cancel out, and what are you left with? You're left with a squared x squared plus b squared y squared plus b squared x squared plus a squared y squared. Okay, and now ferreting this out, okay, if we take this and put our terms properly, we can put these inside of a box and use the box to factor. So here in the upper left, we can put a squared x squared. And what two things do you need to multiply together to get a squared x squared? Well, a squared and x squared, right? And then you continue to the right, we're going to get b squared x squared over here. And so what do you multiply by x squared to get b squared x squared? You get b squared over here, right? And then over here we put what's left, we put y squared over here. So here we get a squared y squared, and over here we get b squared y squared. And so this right here is the product of these things together. And so what we're looking at is what? We're looking at a squared plus b squared. We're looking at this times these added together. And so that's going to be the verification of it. So you kind of have to work backwards on this. That's why this one I think is more challenging.
Okay, don't go anywhere yet.
Okay, yeah. And what I want to do, yeah, so that's kind of fast, but this is one that really took some thinking. I looked at this in the set and worked out the video for this. I had to go ahead and set things aside and sort of work through and think about this a little more. Okay.
So couldn't you have just distributed your 2 and your ay, getting you a squared y squared, and then brought it down and factored it?
What, this here?
In this set, yeah, that part. Like, those two, couldn't you have just distributed your 2, your,
Oh, you mean distributed like this?
yeah, to your...
No, you can't, because what it is, you got the middle. Because if you do that, you're only going to get this and this. You need to get these. And to do this, you have to multiply this times this, and you have to, okay, so you're going to miss something when you do it that way. So that's why you have to FOIL it out or do it in a box like this. Because if you did what you suggested, you would totally miss these things, and you need these things, don't you? Because you need to have this, So this will cancel out this. Okay, we're going to just get started. We probably won't finish the whole thing today. The next set of exercise says evaluate the following polynomials using one or more of these identities. And here, what you have, it so happens that 16 and 17 are going to be applications of this first identity right here. And so what we can do is we can rewrite this. We can say let 40 equal x, and what can equal y?
3.
Let 3 equal y. And when we do that and use this identity, we can rewrite this as 43 squared can be rewritten as 40 squared, right? Plus 2 times 40 times 3 plus 3 squared. And then we can do that. We have 40 squared, which is 1600. And then we have 2 times 40 times 3. What's that going to be?
120.
Be 240 plus 9. And then lastly, we add these together. We get, let's see, that's be 1849, right? And then as a last step, you can check this in a calculator. If you just square that just to check your use of identity, you'll get that right. Okay? So all I want you to do is quickly do number 17. I'll choose somebody to do number 17, and we'll stop with 17 today and start working on the rest of those tomorrow, okay? Okay, I'll choose somebody here. So for this one here, we're going to get Jade. All right, Jade. All right, Jade likes being put on the spot. Okay, Jade, how'd you do this one?
Okay, so I let 30 be equal to x,
So 30 is equal to x,
and 2 is equal to y.
2 is equal to y, okay.
And I did 30 squared plus 2 times 30 times 2 plus 2 squared.
Okay, then you got
30 times 30 is 900 plus 2 would be 902.
2 times 30 times 2.
Oh, okay. 2 times 30 would be 60 times 2 would be 120 plus 2 plus 4, yeah. And then add that up to be 849. What?
Right, is that right?
Yes.
Okay, good, so that's it. So we'll just keep it there today because we just run short of time. And so we're going to use these other identities and sequence here for the next 4 problems. Okay, thank you, Jade.